Hello, this is our project for video interpolation. Uh, our group is composed of Kevin Puig, Tomas Ambrosini, Nathaniel Rowe, Tajay Chamberlain, and Nathan Castillo. In terms of contribution, Kevin Puig worked on front-end, back-end documentation and poster/presentation development. I, Tomas Ambrosini, worked on front-end and poster/presentation development as well as documentation development. Nathan Castillo worked on documentation and poster/presentation development. Nathaniel Rowe worked on back-end development as well as poster and presentation development. And Tajay worked on back-end as well as presentation development. The purpose of our software, this program was created to double the frame rate of a video. This helps to improve the quality of the video and viewing experience for the user. The user can upload any video of their choosing and make it look better than it was previously. So for the scope of our software, it's all about improving a video's frame rate. It makes it so the video is smoother and more fluid. These improvements make the video quality better, which in turn makes the video look better visually overall. This can help make many users' experiences of watching the video much better.
So the software requirements for the video was essentially to have the user be able to easily upload a video through a web interface. The system would assign a unique ID to each video to ensure that there weren't any name collisions. So for this, we use the UUID v4 and a secure random number generator. These videos were then in-queued and set to be processed by a fully trained convolutional neural network to generate the interpolated frames. The status updates must be made available on the front end. So there's a status page that automatically checks whether a video is in the queue, processing, processed, or errored. And once the video has been processed, they would be able to download the final processed video, which contains double the amount of frames. As for the non-functional requirements, the system should be able to respond to user requests within a reasonable time frame. So less than 2 seconds for relatively small uploads or status checks. Video processing must happen asynchronously. So whatever the state of the program at any given moment, the web interface must not suffer from any sort of slowdown. So uploading a video and checking its status is decoupled from the processing of the video file, which is decoupled from the status of the web interface. The interface must be accessible for non-technical users, so no fancy knowledge requirements to use the website. It's just as simple as clicking an upload button. And the architecture must be modular enough to support the level of asynchronous design that we require. So the general structure of the project is a three-layered one. So we have the front end, which is written in React and TypeScript, and this is deployed on a public-facing HTTP server. It simply serves as a basic front end, simple web interface to upload and download these videos. The backend, which is written in Java with the Spring Boot framework, accepts these video uploads from the front end and provides a download for any processed videos. So the backend is simply responsible for handling video file upload downloads and status checks. And then finally, we have the lowest layer, which is the Python processor. It uses PyTorch as the library of choice for the neural network, and it processes these videos sequentially in the order that they were received. So all it does is check four directories: the queued, processing, errored, and processed directories. And then it just processes the videos as needed and puts them in the process directory when it's finished. So all these layers are very much single responsibility and do not rely on each other necessarily to function properly. This modular design made it much easier to debug and scale the application than if we put everything into one monolithic project.
So for how to use the program, um, well, first, this is the homepage of the program. There's the homepage of the website where the user interacts with the software. The top navigation bar has four options, including home button that navigates to the homepage, status button that states the status of a video interpolation, and about button that describes what our website does, and a contact button to contact us with any issues or bugs. On the homepage, you are greeted with our implementation of a video interpolator that allows you to double the frame rate of a video. Under the select video file section, there is a choose file button that will open a files window for you to select video file to be interpolated. The upload new video button will upload your selected video file to be queued for video interpolation.
Once your video file has been uploaded for video interpolation, you may wait for it and check for the status by entering the file name in the entry box. When entering a file name from the home page, it will direct you to check the file status, and it will indicate that file status, whether it's queued, errored processing, or has been processed. And for if you're already on the status page, you can enter a file name and check the file status again, and with all those other options that I stated before.
For our hardware requirements, we just require a modern GPU with a high amount of VRAM, at least 8 gigs for a smaller resolution video.
Now, as far as installation, the front end React, where first we'll navigate to the front end directory using the command cd. To run locally, we'll run the npm run dev. To deploy, we'll also run the npm run build, and then to copy the generated files to the HTTP server for hosting. For the backend, we'll first navigate to the backend directory using the command cd backend and the directory. And then we start the backend server using the executable file gradle w, and then boot run. For the neural network processor in Python, we're going to navigate to the processor directory using the command cd processor to the directory, create a Python virtual environment, activate the environment using the command source bin activate, and then we'll install the dependencies. And you can manually do this using the command pip install opencv python moviepy numpy torch and torch vision. After that, we start the processor by running python 3 processor.py.